Next up, I'm very, very happy to introduce Andrei Ursan, who's a member of our very own Clojure Berlin community and has also been giving talks there. I hope he may do another riff on this one as well. And Andrei will be talking about how he built an IoT data pipeline at the company he's working at, which is called Genie. And he told me before that they had various tries at that and ended up with different architectures at each of those tries. So I think there will be some learnings here, and give him a hand of applause.
Cool. Thank you, Martin. So I'm going to talk today about IoT and real-time data. But about me, so my name is Andrei Ursan. I develop software now for quite a few years, 9 or so. And I mainly like to use Clojure. You can find me on Twitter, or you can write me an email if you have questions especially about this talk. I come from Romania, from a very small city close to the border with Hungary, which is around 60% Hungarian and 40% Romanian. But I spent my professional life in Romania, and I studied in Cluj, which is right in the heart of Transylvania. There are no vampires there, but it's a fun place. The city has like around 100,000 students, which makes the life very vibrant, which is like a quarter of the city are just students, and it's like pretty small. And to that, it's also like around 20 to 30K software developers. In the beginning, it was mainly like outsourcing, but now more startups appear, and there are many nice co-working spaces and things like that. So go and visit it. Plane tickets from Berlin are very cheap, like under 50 euros, and it's a nice place. I lived also like in other places. You can see all the red dots. Also, it's funny how the states just appear, but currently, for the last couple of years, I'm actually living here in Berlin. I actually plan to have way more dots on the map, like to live across Europe, but somehow Berlin, it's just too great, so it's very hard to move out of here. I was basically analyzing, I should move to London, then Brexit happened, I should move somewhere else, but then it's very hard to move out. It's kind of like a trap. Here in Berlin, I work as a software engineer. One of the more popular startups that you probably heard about, it's Wunderlist. And there's here some Wunderlist people that I saw, some of my previous colleagues. And then Wunderlist got acquired by Microsoft. And now I'm working for Genie, as Martin already mentioned. And at Genie, I like to build real-time IoT data pipelines. So before we dive into that, a small disclaimer. These are my own opinions, not my employer. So what I'm going to talk about is what I learned from this challenge of developing an IoT platform. So what's Genie? Genie, like all the IoT platforms on all the many companies out there, want to be a cloud. And that's the Genie cloud. To this cloud, many devices send data. You can have like a fitness device that will send like heartbeat data or your body temperature. Then software developers would actually build apps with this data. Will build apps for your heart rate, or like to show you your heart rate and your temperature. You might think that, why would you do that? Well, just think about Jawbone, which was a company, like I think last year or 2 years ago, they went bankrupt or they had some financial problems. So imagine that now you have a Jawbone device, and all of a sudden you cannot use it anymore because the app for it is not available. Genie proposition in this case would be like, hey, even if if you have the device, you can still use it with our cloud. With other developers can make apps on it. Additional to only these scenarios of apps, you can do even more creative stuff. So imagine you have a smart lock and a smart light, and you can build an app that when you open the door, the lights go on. So that's basically the proposition of Genie. So when I even also proposed, when I applied to talk at this conference, that was like, I don't know, October or even before. I totally had like a different idea about how Genie is going to look in February. And now I'm going to talk about how many iterations we did to explore, to solve this challenge of developing an IoT real-time platform. So, and before we talk about our approaches, I want to introduce two technologies that will be repeated across my talk. First is MQTT. MQTT is a protocol like HTTP, and it's basically focused on speed and delivery. It's also like a pub-sub protocol, and that's basically where the speed part comes. So you connect, you create a connection, you can start sending data without actually need to have other overhead. It's also focused on delivery, so it supports multiple quality of service, like at most once, at least once, and such. And another technology that we use, it's Kafka. Just as a show of hands, how many of you worked with Kafka before? Okay, so there are quite a few. So for those who haven't worked in Kafka, Kafka is many times referred as a message queue, or compared to other technologies like RabbitMQ. However, that's a bit of unfair comparison. You can use it like that, but Kafka is more like a distributed append log. You can imagine Kafka as being like a big distributed file across multiple nodes. So producers write lines in this file, and consumers read data from this file. And when you read data, you also have to keep track of where you are in the file, which line number. Yeah. So as you saw, our first iteration, like first thing first, like we said, like, okay, so how can we build Genie? We said, okay, let's start. We have a thing. A thing is going to, like, can be any device, sends data to our MQTT implementation. Then we have, and this MQTT implementation is going to put, our MQTT broker is going to put data into Kafka. Then we have a worker that fetches data from Kafka, enriches it with more details, say, hey, I see some heartbeat data. From what type of thing is this? Is it like a wristband, a fitness wristband, or is it like a medical device, or what is this? And after it enriches this data with more information, it puts it again in Kafka, and it makes it available to our subscription service. So basically, our subscription service is just a small HTTP API built directly on top of Kafka. And then an application can, authenticate against the subscription service and basically get data. And for the other path, if you actually want to send a command to a device, it's very similar. You send the data to a publisher service, that puts it into Kafka, then a worker says, oh, I want to send a command for this device, again talks with our thing manager, which is basically like a device registry, says, okay, so how is this, what's the MQTT topic for these devices, and furthers, that message to MQTT. So this was basically our first iteration and our MVP. So how is the API looking, just as an idea? Remember that all of this is like a wrapper on top of Kafka. So first, you need to get all the message type shards, which is what's a message type in our case, can be like a heartbeat. Information about heartbeat, that's a message type. Information about temperature, that's another type of message. So first you see like how many shards are there, and which is basically Kafka partitions. Then for one of those shards, you build an iterator, say, hey, I actually want to consume data about, about heartbeat or temperature. Then, after you create an iterator, you can, you start iterating and getting data from Kafka, which basically you get pages of data. And we actually have a logic that you either say, I want to actually get, X amount of records with, and I want a timeout of 100 milliseconds. So for example, if there's no data and 100 milliseconds passed, then basically you get empty messages. Cool. And of course, because with each batch of messages that you receive, you need to know how far have you read, because Kafka. And we also offer a way to actually save this checkpoint on our side. Cool. So what we learn from this? This is very scalable. I mean, if you can start reading, we have no problems on our side. It works. But at the same time, it's a leaky abstraction. I mean, it's not that complicated to see that we are using Kafka underneath. However, that will not be a problem. But let's say that if we would replace Kafka, then our API will not look the same. So to me, it feels like a bit of a leaky abstraction. It guarantees delivery. I mean, this is still arguable, but then you have checkpoints, so you know how far you read messages, and you can go back. But again, it's very complex on the API consumer because now you have to care about basically your checkpoint. Well, the good part is that it works. It's in production, and you can learn about it if you go on genie.io, create a developer account, you can start playing with this. So, yeah, it works, it's there, it's our MVP. We are not necessarily very proud because as we put it out there, that's why a bit like the sarcastic clap, as we put it out there, we started learning that, not everybody is familiar with Kafka. So, first lesson learned is that if you will do a bit more documentation-driven development, like think about how would we explain this to customers, especially if your business is to expose an API, that will be like one good approach. However, one might argue that we did have these questions, but we had many assumptions. We assumed that everyone will be like, well, if you want a scalable HTTP API, this is how it's going to look like. So in our case, assumptions were not only bad, but I will say a bit evil. Yeah, however, this was our first iteration, and it works. Okay, we got feedback. Now what we want to do? So what will be the next step? We want a better API. We want to have real time, like real time. We want to support all the IoT popular protocols like MQTT, CoAP. I mean, you can also put HTTP if you really want to use it. So we looked at all of this and we started to search. And we were a bit biased because the first thing that we looked into was Kafka Connect. So what's Kafka Connect? Kafka Connect has like a proposition, says like, there are multiple data sources out there. S3, Hadoop, Elasticsearch, even blockchain. So we would actually build for you a platform that you take data from all of these systems. You don't have to build anything. And we'll put data into Kafka. That's basically called a source connector. And as well, we can take data out of Kafka and put it into all of these platforms. So that would be like a sync connector. How this looks like, so let's say that we start with an MQTT. You will have a MQTT source. Then data goes into what's this connect cluster. And then this connect cluster will put it into Kafka. And back, it will be put into, you can pull it out from Kafka, having an MQTT sync. So if we look into this, Kafka Connect is basically a cluster. So that already should have been a smell for us because it means like there's going to be this will affect a bit more our current infrastructure setup. And at the same time, deployment and artifact building for a particular connector, let's say an MQTT connector, it's changes. So right now we have microservices that we deploy as Docker containers. And now you have this Kafka connector that you have to deploy, which is some sort of plugin that you put it into. You build a jar, you put it into a path, and then Kafka will take it from you and will manage this process. Everything will be solved for you by Kafka. So yeah, I mean the main advantage is that it integrates very well with Kafka, so you don't have to care about checkpointing or anything else. Just everything works out of the box. Yeah. So this was the first thing that we said, okay, we want to go with this because we want many APIs, and this thing looks like it knows APIs. and protocols especially. And we were also even more ambitious. We said, how do we process data? How ambitious and a bit biased. Because then we said, we should maybe use Kafka Streams. So if you look at the previous picture, this is what we have around connectors. So where do streams fit in this scenario? Streams are over here on the left-hand side. So if a source and a source connector pulls data into Kafka and a sink pulls it out, Kafka Stream is just specialized on getting data from Kafka, processing, and putting it back in Kafka. Now, the good part is that all of these are standalone workers, so not that much changes. And another thing is, like, there is a small limitation. It can only process one topic and then put data again back into one topic. So how is this actually fitting now in our picture, where we put the things? So how we started actually working on it, we said, okay, we have things and applications. They talk with our MQTT broker. Then we are going to have a couple of connect workers that are going to take data out of the broker and back into the broker. And as data is in Kafka, we can just start to process it and put it back in Kafka, enrich it with all the thing types information and such. So yeah, so how did this actually work for us? Well, first, we saw that it's actually very nice. We have like very good integration with Kafka, but then again, all our business logic started to be dependent on Kafka. So maybe the bad side is that we are doing a bit of technology locking. We saw that there are many available connectors, especially also MQTT available connectors, but when we wanted to implement our own was a big pain. So especially in Clojure, because you need to create this Uber jar, and this Uber jar needs to have some class paths that the Kafka itself can actually figure out, oh, where is this class, where is this other class? But let's say that that's easy to do, but then again, your process is run, I mean, this is some sort of Kafka plugin that's basically managed by Kafka. So when you actually start to talk about how do I test this, how do I debug this, it's not that straightforward. There are steps that you have to do, but it's a bit more overhead. However, there is a good part. If you actually are in a situation that you can use a connector that's already built, there is good community support around it. But this is, usually these connectors solve like a more generic problem. So if you have like a bit custom, it might be hard to actually convince a community connector or the community of a connector to change it for your particular problem. Yeah. And however, we worked on this a couple of, I would say, quite a while. And the conclusion is that we failed. And we failed in a funny way. So the reason why we failed is that I think we put a lot of assumptions on, we were a bit too hypnotized by all these integrations that Kafka Connect provides out of the box, S3, Hadoop, everything. And we said, this will just work. I mean, it's what we want. And it's not. It's basically, connectors are very good if you have lots of these data sources in your system, like you have Google Analytics, you have S3, and all these events come from multiple sources, and you want to do something with them. We want to aggregate them and do some data analytics. For that use case, it's very good. But building an API on top of a connector is a bit more complicated. And also, Kafka should probably not be the core of your product, but maybe should just be a tool, like what it is. So yeah, what did we learn from this? Well, if you just have like a simple use case, like you just want to have like a simple consumer and producer, start with that. Only if there is actually a community supported connector that really fits on your need, then just go for it. But at the same time, think that if you only use one connector, you have to add like a new concept to your stack. You have to add the Kafka Connect cluster. this was basically, I like a lot Clojure for Java interop, and when you need to go and use a library in Java world is very good. However, being spoiled by the functional approach of Clojure and you have to do subclassing and you have to care about all of that is just not fun. However, Kafka Streams work pretty nicely, even though you still have to subclass to implement it. And we think that, or at least that we did not ask the right questions in the beginning. Like, oh, we want to do this, we want to add this technology to our stack. How do we debug it? How do I test it? And all of these questions, which I think would have made us like, maybe we should not go this path. And then this brought us to the iteration number 3. So we worked on that. It did not work. We said, okay, we just dump it. We failed. We learned something. So where can we go next? The first thing was, should we still go on the initial approach? And it was like, maybe less Kafka, or at least not think about, let's use this tool, but start thinking about requirements might actually be better. And so we started to look again. We recognized that, for the real-time part, we don't even need any Kafka. We can just receive data into our MQTT broker. And in this case, we are using eMQTT, which is an Erlang implementation. And this one in particular supports adding some plugins. So for example, even if you want to do it, like it has like a built-in Kafka plugin. You can just say all the data that I get in MQTT, put it in Kafka. At the same time, it has other HTTP plugins, and you can make your own. So for example, when data comes from a thing, in our case, it goes to our MQTT. We see, do we have an application that's connected to this thing? Say, yes, there is. And then we say, is this application having an MQTT connection with us? Yes. Then, okay, send this information. So all of this decision happens exactly into the MQTT broker, which is, let's say that we get more real-time or real-time. Then, if we really want to add Kafka, for example, we want to make like a historical data API, you can just add the plugin, and then you can enrich the data, put it in some sort of data storage technology. Probably it's misleading having it there over as a data lake, and then you can expose that via HTTP APIs. And at the same time, we can also support our legacy API, just dump data into MQTT and expose it via HTTP. So what we like about this approach, first is more like real-time. And it's also like it's a bit easier to explain, right? I mean, you say to a device manufacturer that also has an app, hey, we have MQTT, your device can talk MQTT, your application can also talk MQTT. It's easier to explain now. It's still to be done. I mean, it's one of some construction sites that we had, and it's not like a pain point, because I mean, we do enjoy all our construction sites because we learn a lot, especially in this world of like new technologies appearing each day, like IoT, blockchain, and all of that. So lessons learned, of course, maybe at the next clojureD. But the summary of it is like, if you want to make an API, think about making it beautiful, as my colleague Dave would have said, like make a beautiful API for your customer. We learned that Kafka Streams are nice, and implementing Kafka connectors, especially in Clojure, it's a bit of a pain. Clojure Java interop is nice, but when you really have to do Java stuff and all the subclassing, it's not so fun. I actually started writing a macro to get rid of this, but then the first rule of macro is like, don't write a macro. So it was a bit of a conflict. Yeah, be critical when you choose your technologies. I mean, ask some questions like, hey, how do I debug this? Is it easy to test? And I think we did this very well. I mean, we learned from our mistakes and said, okay, maybe we should not go Kafka all the way. I mean, I don't want to argue. Kafka is it's a very good technology. We'll probably continue using it. I also I have like my own personal challenge where I actually want to build a bit more Clojure tooling around Kafka connectors to make it easier. We'll see how that flies. I think connectors are in general pretty powerful, and I think they are 1 year old or 2 years old now. I mean, it's pretty young technology, so I think it's going to also improve from the Confluent side. But yeah, fail fast, learn, repeat, and have fun. I think we definitely, so I know that failing, it's a bit like a pain, but I think if I look back on how we worked on all of this, was kind of like, maybe we were a bit sarcastic sometimes, but I think we definitely, we did it like in a joyful way. So yeah, that's it. Thank you.
Thank you very much, Andrei. And with that, we might have time for some questions. There we go.
First of all, thank you for your talk. How long were these iterations, and how did you figure out that something was going wrong?
So I think we started, so the first version, the iteration 1, I will just give you from top of my head like some timelines. I think it started being worked on around June, July, and it went on to the state probably September-ish. So that was like the first version. I mean, what you saw over here is just a piece of our architecture, the real-time part and the API. We have like device, we also have like OAuth side, like how an application connects to us and everything else, and all the device management. And then the second iteration, we started around in beginning of November, and it went until close December-ish, the beginning of December. And now, and then I think for 4 weeks, we kind of figured out that's a bit of a pain to work with connectors. And it was like 2 engineers, 3 engineers, something like that. And with the current one, the third one, although it's not yet, it's not yet in production, we did do some more exploration work around it. Will this be possible to use EMQTT in the fashion how we wanted to use it? And the only pain that we will see there, and we have to do a bit more load testing, is like, will it be able to scale this Erlang cluster? I mean, so far what we read and what we tried to find information out there is that it behaves very well. But we will, again, if that fails, we will definitely have other options that we want to explore.
Great, thanks for the question. Do we have more questions? No more questions? Okay, then let's give Andrei. Oh, okay. There was a bar between you and me.
Just a short one. When you are talking about difficulties of subclassing in Clojure, so why don't you just use Java for those parts when you need to deal with interop heavily?
Yeah, I mean, it's a good question. So although this talk doesn't show that much Clojure, I think all our team is kind of like enjoys writing more Clojure. And because if it will be just to do Java part, then it's like, why not just write the entire connector in Java? So I think to answer your question, I think we just find more joy writing Clojure, or at least yeah. But it's, even though then we started to explore writing our connector in Scala, which we already found like an MQTT connector written in Scala, so we wanted to extend that one to fit our needs. We still found it like a bit difficult to debug and test, and we just abandoned it. So yeah, we tried, but we still did not fit with our, yeah.
All right, cool. I think with that, we need to end the questions because there's another talk upcoming before the coffee break. And let's thank Andrei once again with a round of applause for his talk.